This is the first of a 7-video series on factoring. General concept. So before we get into our video series about factoring, let's examine what factoring is. What this video is not, at least part 1 of the 7 of series, it is not a how-to video. You'll see nothing here about how you actually factor. But it's worth spending a little time analyzing what it is. Here's a math problem that you may be familiar with from the past. If I were asked to multiply these two binomials together, I might use a process called FOIL. You might call it something else. You might eventually end up with this as your answer. Now, if this kind of polynomial multiplication is not something you're comfortable with, you definitely don't want to watch the factoring series of videos. You're going to want to go back to a video called Polynomials Multiplication and familiarize yourself with that. Factoring is not a useful endeavor if you're not familiar with polynomial multiplication. Assuming you're comfortable with this kind of multiplication, let's continue. Let's take the work out of here. It's traditional in these kinds of problems to consider this as the problem and this as the answer to the problem. But what is factoring? Factoring is in some sense a process that reverses this. In the world of factoring, we consider this the problem and this the answer. Let me say a little bit more. Factoring means to express as the product of primes. A prime is something that itself cannot be expressed as a multiplication problem. So for example, this is prime because I can't express it as something times something, and likewise this is prime for the same reason. Now before we go any further, I'd like you to follow me on a little mental journey that seems a little bit off the path here, but bear with me. Suppose I were to evaluate these expressions when x is 29. By the way, let me tell you where I got that number. Today, when I'm recording this video, happens to be the 29th of the month, so it seemed like a random enough number for me. Why we're doing this, you'll see in a minute, but imagine we wanted to evaluate both of these when x is 29. So I've plugged 29 in for those two x's, and I'm going to plug in 29 for those two x's. Now what I did is I reached for a calculator, I used the order of operations, and I worked both of these expressions out. And guess what? They had the same answer. Now the number itself is not relevant here, nor is the number 29. But what is relevant is the idea that these two polynomials, the x minus 3 times x plus 5 on top, and the x squared plus 2x minus 15 on the bottom, have the same value no matter what x is. Now when we're factoring, we don't have any particular values of x in mind. But it's worth noting that if you were to pick a random number for x and plug it into your factored polynomials, you'd get the same answer as in the standard form polynomial. So even though for the purposes of previous math we may have thought of the top expression here as the problem, and for the purposes of factoring, we'll consider the bottom expression as the problem, it's really worth noting that these are really just polynomials that have the same value, and they're in different formats. This format is called standard form, this format is called factored form, and they're the same polynomial essentially. Now let's consider this. Wouldn't this multiplication problem here, this factorization, if I were to multiply it out, wouldn't it also have a, quote, answer of x squared plus 2x minus 15? It would. So in the world of factoring, we consider this the problem, and either of the things on top would be, quote, the answer. They're essentially the same factorization. So we don't spend a lot of time worrying about the order of multiplication, because as we know, order of multiplication doesn't change the results. And likewise, the order of your factors there's no preference there either. By the way, final note on this problem, you see the little dot as the time sign between the factors? We rarely write that, so don't expect to see that dot forever. Let's look at another problem. Now remember, this is not a how-to video. I have not gotten to the point where I'm showing you how to factor. That will start in video 2. But for now, imagine this multiplication problem. Imagine I were to multiply the first two factors and then multiply those using maybe FOIL or some other process that you may know the name of. Regardless of what you call it, again, in past problems, we might have thought of the bottom expression here as the answer to this multiplication problem, and in a sense it is. But here's something to ponder. Isn't this 5x squared plus 10x minus 40, isn't that the standard form of either of these two multiplication problems here? Which raises the question, if I were factoring 5x squared plus 10x minus 40, which of the top two products would be, quote, the answer? Well, remember, factoring is to express as a product of primes, things that themselves cannot be broken into a multiplication problem. This is prime, this is prime, this is prime, and this factor is also prime because none of them can be expressed as a product. This, however, is not a prime polynomial. Why? Because this thing in the box can be rewritten or expressed as the product shown here. And therefore, even though both of the two things on top here are polynomial multiplications whose result is the bottom line, we don't consider the one on the right a complete factorization because one of its factors is not prime. So in the context of factoring, we would consider this the problem and this the answer. Now, so far all I've told you is that essentially factoring is the reverse of multiplication. And that concludes video 1 of 7.